Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. Today, we are going to present, which is our title is Transient Heat Conduction Time and Temperature. And we are from group B9 and our course is Introduction to Programming Language. Without wasting any time, we will introduce ourselves first. My name is Muhammad Afan bin Isa and my meeting number is 2022591.
Hi and Assalamualaikum. My name is Muhammad Akib bin Nasaruddin and my matrix number is 202592.
Hello and Assalamualaikum. My name is Muhammad Wais Akil bin Azari. My matric number is 202459.
So, first and foremost, we'll proceed with the introduction. In this problem of varying transient heat conduction, time and temperature distribution in a semi-infinite solid is investigated. Varying heat flux means that the heat transferred to the solid by its surrounding is a function of time with the particular problems. A semi-infinite solid is one which is bounded by only one plane. This subject has achieved considerable importance in the field of space technology. The study of temperature stresses due to non-uniform heat flow is also important. Solutions to this type of problem are presently based on estimated initial surface temperature and its variation with time rather than on premise of the exterior heat flow itself. It is the purpose of the study to aid in the prediction of temperature within a semi-infinite solid as a function of time and heat flux, without regard to the type of heat flow to the solid or the temperature surface. We will proceed to the project background. Semi-infinite solid is an idealized body that has a single plane surface and extend to infinity in all directions. A thick wall can be modeled as a semi-infinite medium if all we are interested in is the variation of temperature in the region near one of the surface, and the other surface is too far to have an impact on the region of interest during the time of observation. In this problem, we will examine the temperature in the semi-infinite solid in two ways. In the first way, the temperature is plotted over the range of the eta 0 to 5 and tau 0.01 to 3. In the second way, the temperature is plotted as a function of tau for range of 0.01 to 4 at the eta 0, 1, 2, 3, 4, and 5. From these issues, we can examine the temperature in a semi-infinite solid as a function of non-dimensional position, eta, and non-dimensional time, tau, and we also can examine the temperature in a semi-infinite solid as a function of non-dimensional time, tau, at several non-dimensional locations, eta. So that's all for the project background.
Okay, for the program development, we use three applications of MATLAB. First is through a two-dimensional plot. Second is three-dimensional plot, and the third is loop structure to solve the engineering problem. Okay, for the script file, okay, there is a script file for the 3D graph. So the input for the graph is tau and eta. So we use linspace to generate a 30 space vector between 0.01 until 3. And for eta, we use linspace to generate 20 space vector between 0 and 5. So the number of space vector between tau and eta is different. So we cannot substitute to theta formula. So we use mesh grid. So we use mesh grid, eta and tau to transform the space vector into array x, y, which can be inserted into the theta formula. So the theta formula is ERFC 0.1 multiplied by x divided by y minus exponential x plus y power of 2 and multiplied by ERFC 0.5 multiplied by x divided by y and plus y. So the 3D graph will put into the figure 1. So to plot the three-dimensional graph, we use mesh plot. So x, the eta, x axis, y, tau is at the y axis, and theta at the z axis. So and finally, we label the axis for the graph. So for x axis, we label theta, and y axis we label it as tau, and z axis we label as theta. Okay, for the two-dimensional graph, we put it at the figure 2. The input for 2D and 3D is different. For the 2D dimensional graph, we use eta. We put the eta input value is 0 until 5, and tau, we use a least space to generate 40 space vector between 0.01 until 4. And same as the 3D dimensional graph, the number of the space vector were different, so which makes grid. So the eta and tau can be substituted into the theta formula. The theta formula for 2D and 3D is same. So okay, for the xt and yt is indicate the x coordinate and y coordinate at the graph. So x coordinate is 3.5 and the y coordinate is 0.x. So for 2D graph, we need to put a 6-line graph at the graph. So at the same figure, so we use for loop structure. K equal to 1 until 6. So the loop structure will repeat 6 times. So first the loop in the loop structure we plot a tau against theta, and we need to label between the line graph the value of eta. So we use string eta equal to number string eta k, and for the coordinate for the string we use xt coordinate, which is 3.5, and y coordinate, which is 0.6. And so for y coordinate, every time the loop structure will repeat, will minus 0.12. So the coordinate between the string were different between the eta. So finally, we label the graph. X-axis is tau and y-axis is theta. So that's it for me. So I'm gonna pass it to Wise for result.
Okay, for the result, we will have a two graph, which is the 3D graph. And we will see that kind of wave shape. And for the 2D graph, we will have a 5-line, which is with the eta 0 till 5, right? 6 line, sorry. And for the discussion, okay. Next, the comment of mesh grid, eta and tau, transform the vector eta and tau to array x and y, which can be inserted to the function and make the 3-dimensional graph. For loop was used to construct 6-line graph in the same figure for the eta. And the eta and tau was the input, while the graph 2D and 3D are the output. For the conclusion, the reading in the 2D graph, which is the theta against tau, is increasing exponentially from 0 to 0.9. When eta equal to 0, the graph become more linear when the starting point is increased. And at eta equal to 5, the graph nearly become linear. Thus, when the theta is smaller, the temperature, which is tau, will increase more quickly, and the time for the temperature is to increase is lesser. The reading in 3D graph is the same with the reading in 2D graph. In 3D graph, we will see more clearly when eta is increasing. The theta is smaller. That's it from our presentation today. Thank you for listening.
Thank you.